Kathleen, are you okay for this kind of question? Can you solve this by yourself?
Wait, I think so.
So this thing, you just do the logarithm for both sides. You can take the natural log, which is using e as the base. You can also use the log base 10. And the final result doesn't matter if this is a ln or if it's log 10. It's going to give you the same answer, okay?
Okay.
Yeah, if you have specific question, you can ask me. For worksheet C, worksheet D, does anybody need help for worksheet C and worksheet D? Nobody need help? How do you know if ln or log is better to use for this question? So if you have the e, you know that you want to take natural log, right? If you have base of 10, you want to use log base 10. But if you have other number rather than e or 10, use either natural log or base 10, no difference. Saying this guy, if you use log base 10 or log base of e, give you the same solution. So this one, if you change, this is base log base 10. If you change this to the natural log, the answer is the same. So for example, if you do this to be, change this to be natural log. These two answers are exactly the same. It is identical. You might feel curious. This looks totally different. Why these two are the same? It is because of base change rule. So last class, I talked about the base change rule. We can figure out why these two expressions, even though it looks so different, but why it's the same. So first, let's check over here. Let's see these two numbers. The first one, I will use log base 10. This guy, you don't have any number there, that means log base 10. So you do log 4, and then you minus. Outside, you do log, another log. And then this is 6. So here it's minus. And in front of this is -2 times this. And then for the bottom, you will put log of 6. So you will do this guy here. This is 6. And then over here, it's -3 times. You do this log 4. So you have this expression. And you may feel curious, how come these two guys are the same? So let's do this. I click here, and I click this, copy, so paste. So this give me this. And then I'm going to change this log to be ln. And then here, I will change this to be ln. And over here, ln means natural log. Okay, so as you can see, these two, even though these two looks totally different, but these two results, when you type into the calculator, it is identical. These two guys are exactly the same. Now I'm going to use the logarithm property to prove these two are the same. So let's do this proof. Everybody know the question now? We want to say, this give you the same answer. Now I'm going to show you why these two guys are the same. So the reason these two guys are the same is because let's go for the properties. Kathleen, let's go here. So you have these two. For the log property, you can put 2 into the fourth shoulder. It's going to be 4 square. Make sense?
Yes.
So this becomes negative log. 4 square is 16. You have a negative negative, so you can put this negative outside. You can plus a log 6. So far, so good?
Mm-hmm.
And then for the bottom, you treat this as log 6, and then you do minus 3 will put as fourth shoulder. So this is a 4 to the power 3, which is
64.
64. After that, you can tell me this is who? This will be how much? Based on the...
Log 16 times 6.
Yes, exactly. So this is negative log 16 times 6, which is 96. Make sense?
Yeah.
Right. And then for the bottom, this is log. When you have a minus, what do you do between these two numbers?
6 over 64.
Yes, 6 over 64. So this guy is this. And then we have this. The base change rule is saying if you have a log a of x, you can write down this as ln of x over ln of a. You can also write down this as log base 10, which you don't need to write down any number. You just write down x. And then you write down this, and then you put a here. So that means this guy, if we manipulate with this formula, you can leave the negative outside. If I leave this negative outside, I can treat this as my base number here. I will put 96 over here based on this base change rule. Does this make sense to you?
Yeah.
You put 6 over 64 over here, and you put 96. That's what's going on. Okay, so this equals this. So far, so good?
Yeah.
Next, Vienna, let's do here. We are going to manipulate the property, okay? So we will take the negative out. When you have this 2 here, I want to put this one here. So what you have this?
Is it 16?
Yes, 4 square is 16. You put the negative outside, so you will plus ln of 6. So far, so good?
Yeah.
And then you will have the bottom ln of 6 minus. You want to put this one over here. This becomes to who? 3, put fourth shoulder. This becomes 4 cube, right?
Mm-hmm.
So this becomes to 64. And then what you have? You want to do this property. Go ahead. This become? Go ahead, Vienna. This becomes negative ln of who?
Wait, do I just add them?
You do this multiplication.
Oh, yeah, multiply them?
Uh-huh. You do the multiplication. That's a property.
Oh, 96.
Yes. And then for the bottom, when it's minus, you will do this 2 division. Correct?
Uh-huh.
So that's it. And then based on this base change rule, this give you a negative. This is natural log, which is this. So you want to choose this guy on this base location, and you put this 96 over there. Does this make sense?
Yeah.
That's why these two are equal. So some student ask me, should I use base 10 or natural log? Will there be a difference? There's no difference. The result, if you do correct, the result will be identical. It's the same. Okay? Any other question here? For the base change rule, does anybody still feel confused? I will walk through this with you again. Everybody know how to apply the base change rule? So the base change rule is working like this. You might feel curious, how can this looks so different? How can this be always true? We just make m equals to this. So x is going to be a to the power of m. And then if you have ln of x here over ln of a here, you can put ln and then a to the power of m over ln of a. Based on the property, you put this m in front. This is m times ln a over ln a, which is m. That's why this m equals this m. So these two are equal. Same thing. You can make this guy plug into here. This become m times log base 10 of a over log base 10 of a. This cancel, so it is still m. So when you have a at the base x here, as long as you choose a new base number, you will put this on the upper, put this on the down location. That's going to be always equal. This is called a base change rule because you change the base. The previous base is a, now your base is e. Now your base is 10. Okay, that's what's going on. Any questions so far? Okay, let's do this because I think your school will have the logarithm test very soon. Go ahead, I ask you, draw these two graph by yourself. Don't confuse yourself. The exponential function will have a horizontal asymptote. The logarithm will have a vertical asymptote. For both, this asymptote cannot be passed. And go ahead, answer those questions. Do it on your own paper. Do it quickly and perfectly. I send my phone number again. You can send me your answer with your work. If any student you miss several classes and you totally forget how to draw this or how to draw this, You can unmute yourself. You say, teacher, please help me. I will go through this with you together.
Can you please go through it with me?
Okay.
Yeah, I also need help.
Okay, let's go through this. So let's first draw the exponential stuff. The way we draw the exponential are based on what we have learned in Algebra 1. To draw this thing, okay, let's see. First, let me do this. Before we want to draw it, we want to answer those easy questions. For this domain, x could be any number. So this is just negative infinity to positive infinity. You need to know at least 2 to the power of x. This base is bigger than 1. It's going to grow 2 to the power of x. That is the parent function, right? And then you want to know the range. Look, 2 to the power of x is greater than 0, always greater than 0. When you have this shift to the left, it's not going to change your range. Shift to the left, to the right, will not change your range. And then when you have a negative, so basically you put this negative, this will be less than 0. And when you plus 8, you will be less than 8. But you couldn't equal the horizontal asymptote for exponential function. The asymptote couldn't be crossed. So you have negative infinity to 8. Next, x-intercept. X-intercept, who is a girl? Unmute yourself. Do this with me. You want to make this equal 0, right? We solve it. So we make negative 2 to the power x plus 1 plus 8 equals 0. So this makes negative 8, right?
Yes.
And then 2 to the power x plus 1 equals 8. X plus 1 will be
3.
3. X is
2.
2. So x is 2. So this will be 2 comma 0. Y-intercept, you make x as 0. When x is 0, this is 0 plus 1, which is 1. How much is this then?
6.
This becomes 6. Does this make sense?
Yes.
Asymptote. Asymptote is a horizontal line, so it's going to be y equals to 8. Correct? Increasing, decreasing. We can answer the question without graphing it. This guy is increasing. When you have a negative, you will flip down, so it's going to decreasing. So you will say, okay, this is decreasing. After we have all those points, we want to first always draw the asymptote. So 1, 2, 3, 4, 5, 6, 7, 8. All the way to here. This is a horizontal asymptote. You mark, that's several points. 2, 0, 0, 6. Okay, so you have this. And then this is decreasing. So as a horizontal asymptote, you can only go that way. There's no way you can say, oh, you draw something like that. No, you want to approach this. So it has to go down like that. It has to go down like that. So you will connect. Okay. Like this. This finished that. Let me check students' work. Yeah, Catherine get every part correct. Very good. Claire also get every part correct. Andrea also get every part correct. That's pretty good. Anybody else? Next, let's draw the logarithm. Okay, Kathleen, let's do number 2. Let's see over here. You want to find out the domain. As the logarithm, the log and exponentials. So now everybody believes these two, even though it looks so different, but it is identical. Okay, these two look so different, but it's identical. Now, we need to know the two functions. If you say 2 to the power of x, this is the exponential function. When you do log base of 2, if you do log base of 2, and then you put x here, you have this inverse function. When you do y equals x, these two are exactly symmetric over y equals x. These two are exactly symmetric over y equals x. That's called inverse function. So you notice that log and this ln means e, base of e. E is greater than 1. So ln x should looks like this. If you have the ln x should be like this. This is e to the power x. This is ln x. They are symmetric over y equals x. This is a basic shape. And then what happened for here? When you have 4 minus x, you want to keep in mind ln negative of x minus 4. So what this guy did? This guy shift to the right by 4. Okay? And then it's going to do a reflection. Or you can say, I do a reflection. Inside here, you do a reflection over the y-axis. Fx and f parenthesis negative x. This is symmetric over y-axis. You do a reflection over the y-axis, and then you shift to the right by 4. And then you shift up by 2. That is the transformation from the parent function. Domain, a guy here has to be always positive. So what's the domain, Kathleen?
Negative infinity to infinity.
You want to be less than 4, right?
Oh, yeah.
It couldn't be negative. This thing has to be greater than 0. Yeah, you see the curve here? The purple one. It's not going to touch the y-axis. It's very close, but never ever. It couldn't be negative. The log 2x, x is positive. It even cannot reach to 0. So this cannot be closed. This is open. How much is the range?
It's going from positive infinity.
Yes. The log, the y direction is from negative infinity to positive infinity. Okay. X-intercept, we want to solve it. We make this equal 0, right?
Yeah.
X-intercept make your y equal 0. Let's see, then ln of 4 minus x will be?
Negative 2.
Negative 2. So 4 minus x become?
Is it like you do the
This is e, so e to the power negative 2. Correct?
Yeah.
And then x become 4 minus e to the power negative 2. Okay? Make sense?
Okay.
Yeah, you move x to this side, you move to this side, so that's 4 minus this. Who is this? This is 1 over e squared, okay? So this is 4 minus 1 over e squared, comma, 0. Make sense?
Mm-hmm.
And then y-intercept. You make your x as 0, so your y is 0, comma, ln of 4 plus 2.
Yeah.
Okay? Asymptote. Who is the asymptote?
When it's equal to 2?
Which one? This logarithm has vertical asymptote. This guy cannot equal 0. So make that equal 0 will be your vertical asymptote.
So y equals to 4.
X equals to 4. X equals to 4. Vertical line is x equals to a value. Horizontal line is y equals to a value. Make sense?
Yeah.
X equals to 4. Right here. And then you want to give a few points. So 0 ln 4 plus 2 is going to be how much? The ln of 4 means you have roughly 2.7 and 4. Okay? So this guy is going to be greater than 1. It's between 1 and 2, right?
Yeah.
Between 1 and 2. So this value you can put, but plus a 2. So you plus 2. So it's going to be between 3 and 4. So you will choose a point between 3 and 4. Yeah, roughly over there. And then you want to figure out the x-intercept. You treat this as 2.7, or you can treat this as 3. 3 squared is 9, so 1 over 9 is about 0.1. And 4 minus 0.1 is roughly 3.9. And then you will leave a x-intercept at around 3.9. Around here. You have these 2 points, you have the asymptote. There's no other way you can go. Your curve going like that. You have to follow this trend. You won't be able to draw this way. You can only draw this way because you want to be along this asymptote line. Does this answer your question?
Yes.
So you have this. Okay. Let me check students' work. Daniel, you marked the point, but you need to draw the curve. Anybody finish this logarithm graphing? Does anybody still feel confused about this graphing? I know people don't like E because E is a number. You can never ever know how much it is. But you don't need to remember so many numbers, and you don't need to use so many digits. You can just make it close to 3. You can use 2.7. You can use 3. It's good enough for you to draw. Your teacher will not give you points off, say, oh, this point is not exactly. If you between these two, it's good enough. You have this asymptote, you have the trend correct, you have all those individual questions correct. That's good enough. Now we are going to do this kind of questions. Yeah. Good job, Annie. Good job, Claire. Now, Haley. Go ahead, tell me what we can do for number 1. Haley, go ahead. This equals how much? Haley, I cannot hear you.
I'm sorry.
This is who? You put 3 to the power 1/2, right?
Yes.
So this is 1/2, right?
Yes.
So you can say, okay, log base 8 and then 1/2 equals to what? One-half is 2 to the power -1, right?
Yes.
And 2 is 8 to the power of 1/3, correct?
Yes.
So this is 8 to the power of -1/3. So you change 1/2 to be 8 to the power of -1/3. When you have these two numbers, you pull this in front. Log base 8 is 1. So this is exactly -1/3. Make sense?
Yes.
That's what's going on. Number 2. Annie, let's do this together. How do we do this one? 16 want to change to who?
You can do 2 to the power of 3. No, sorry.
2 to the power of how much?
4.
So, and 3, this is cubic root. That means 2 to the power of?
1/3.
So these two together, 16 times this is 2 to the power of 4 and 1/3, correct? And this is 4, so you can change 2 to be 4 to the power of 1/2, right? And this guy, let's change this to a improper fraction. What's this?
13/3.
13/3. And then you will do that to multiplication. So this is 13/6. Okay. And you can put this guy in front. This is 13/6. That's it. Make sense? Okay. If any student, you feel confused, ask me, please. Next, we will do the composite function. You have fx, you have gx, you have hx, you have rx. And this looks ugly also. You want to put 5 first into g and then solve this. So we will do step by step. Let's see here. Daniel, let's first get g of 5. G of 5 is how much? G of 5 is who? Daniel, unmute yourself, answer my question. I cannot hear you. So this is 4 to the power of 5, right?
You know.
Yes.
Okay. G to the 4 to the power of 5 is 1024.
You don't need to do that because you have the next step, right?
Yeah.
Yeah. Don't spend your time for figuring out how big this number is. Based on this base, you want to change this. So you want to convert 4 to 2 square, right?
Yes.
4 is 2 square. square to the power of 5. So this is, oh, this is log base 2 and then 2 to the power of 10. So how much is this then?
10.
10. You pull the 10 to the front. This is 10. Okay. Next one, Vanessa. Let's do the inverse function. You are looking for H inverse. We make y equals to this. The way we do the inverse, we will first write this and we will flip x and y, right?
Yeah.
Now let's move this around and we solve the y.
Okay. X plus 1.
And then divide by 2,
Oh.
right?
Yeah, divide by 2.
Equals,
Equals 3 to the power of y plus 2.
and then how do we solve y plus 2? Y plus 2 equals,
Equals
log
3,
yes,
and then x plus 1 over 2.
right.
Mm.
This is
And
called
then-
the base. This is also the base location, okay? And then
Yeah.
one more step.
Yeah, and y equals
That
log
guy
3.
minus 2.
Yeah.
And then that's a H inverse.
Mm.
Okay, this is how
Yeah.
we do the inverse. Next, this one here. Catherine. Let's do this guy here. They give you F inverse -2. And when people see this, people feel very confused. When they ask you solve F inverse, you can solve the F inverse too. You can say F inverse -2 is saying make this guy y value as -2 and solve your x. It's the same meaning. So when you see F inverse, basically you are looking for F, but you make the Fx output equals to -2. And then you'll solve your x. X will be this one, you solve x. X is how much? Okay. This is the base. So this guy to the power of -2. Make sense?
Yes.
So this is 2 to the power of -2, which is 1/4. Okay? 1/2 to the power 2 is 1/4. And then you will use this guy as an input to this, correct?
Yes.
When they give you F inverse, you make this output equals to this guy. Solve the x. That is your F inverse. And then you drag this one as input to gx. So x is 1/4. So this is a 4 to the power 1/4. It's not complete yet. 4 is 2 squared. So 2, this guy. This is 2 to the power 1/2, which is square root of 2. Anybody feel confused? Ask me, please. That's what's going on. Make sense? Next one, inverse function for this. Vienna, let's do this one. This is Rx, and you want to solve this guy's inverse. Go ahead, let's solve it. Tell me how you do the inverse. Vienna, go ahead. You make y equals Yeah, so first step, write down this and switch x and y. And then let's go ahead, move this, right?
Yeah.
So you will have x minus 2 over negative 3 equals to this. Okay, and then we solve the 4 minus 1 will be 4 minus 1 will be, this is base e, right? So you will have e to the power of that whole thing, right? And then you want to solve the y. So y will be 4 minus this whole package. Y is 4 minus this whole package. That's it. That is the inverse function. So in this few example, we solve the composite function one layer in the other, and we solve the inverse function for both exponential and the logarithm. And then we will do the simplification. Number 4. Claire, let's do number 4. I'm going to delete here. Let's first take care of this. Who is this?
ln of 48.
And then we will pull 1 over 3 to the shoulder. So this becomes to ln 48 to the power of
1/3.
1/3. This guy and this guy is plus. So what do we do?
ln of 2e times 8e.
So that is ln of 8e, correct?
Yeah.
And minus means this guy is going to be in the denominator, right? So we will put cubic root of 48 over here, correct? That makes sense?
Makes sense.
Yeah, but sometimes the school teacher don't allow you to leave the radicals in the denominator location. So you want to times something to cancel or get rid of these radicals. What number you want to times here?
Cubic root of 48 squared.
So we don't need to times so big number. Let's see, 48 is who by who?
8 times 6.
8 times 6. Right? 8 is already a perfect cube number, so we don't need to times this. We only times 6 squared. It's good enough. Make sense?
Makes sense.
So we will times cubic root of 6 squared for the top and also for the bottom. And then the bottom one, this guy is 8 by 6, so 2 can go out. And then when 2 go out, you have a 2 cube, 6 squared, so 6 can also go out, right?
Yes.
So the bottom is this, and then the top is 8e, cubic root of 36. Okay, and then one more step. 8 canceled. So this guy, 2, so this is 3. This guy divided by 4 is 2. Okay, so it's going to be 2e times cubic root of 36 over 3. That's it. Does anybody Need help or have additional question?
So when you want to put the radical on the top, why did you multiply by 36? I mean 6 squared.
Because 48 is 8 by 6. This guy is already a perfect cube number, so 2 can go out. You have this. So you don't need to times the guy to make this. It's already a perfect cube number. You can take it out. So that's why you only times cubic root of 6 squared, so that you can take 6 out. Make
Okay.
sense?
Yeah.
And then the top one, you times by this, so you have a 36 left. And then you cancel this. Divided by 4 is 3, divided by 4 is 2. Okay. Any other question here? Number 4. When you put, if you don't put 36, when you put 6, cubic root of 6 times cubic root 6. This is cubic root of 6 squared. This is 2, this is 3. You cannot get rid of this radical yet. Does this answer the student question? Some people say, why you times the 6 squared? Because you want to get rid of this cubic root, you have to make it inside to be 3. Any other question here? This part is very easy to make mistake. Next. Andrea. Let's do number 5. You have this multiplication. You will make this 2 plus together equals ln of E plus ln of this, correct? How much is this? Base of E, so this is 1, right?
Yes.
And then how do we take care of this? This is 1. This is ln of E to the power of 1 over x, correct? So this is 1. So you put this in front. That is 1 plus this. Make sense now?
Yes.
Okay. Next one is going to be also complicated. This one is a bad guy. Cindy. Let's see here. How do we do this one? When we see this thing, we want to take care of the guys by some kind of order. So we don't want to manipulate it with a minus first. We want to take care of those positive things first. Okay?
Okay.
You can treat this as a 1/2 in front. And then you will pull this 1/2 over this shoulder. Okay?
Okay.
So you will have 1 plus log, and then 5x. This is 1/2, which means you have a square root. Make sense?
Yeah.
And 2 pull over here, that's it. That is
3 squared,
which is 9.
9.
So you will do this guy times 9, right?
Yeah.
You will do this guy. You pull this 1/2 to this shoulder, it is this. You put this one here, it's 9. So you put this 9 in front. Okay?
Okay.
And then your minus. You will pull this one on this shoulder. This is 3 over 2. Okay,
Okay.
so far so good.
Yeah.
Next, you have a minus. And then that means you do this divided by this, right?
Yeah.
So this become 1 plus. There is no number here. By default, it is 10. This is log. You have 9 times square root of 5x. Do the division. X to the power this is x times x to the power 1/2, means x times square root x. Okay?
Yeah.
X times square root x. And now you feel happy because that part can cancel. Okay?
Okay.
So you have 1 plus log 9 times square root 5 over x. Some people come here feel confused. How do I do this? What do you think?
You can like make it log
One,
of a number, like
One-
log of a number to the same number.
Sure. Log of who give you a 1? This is 10.
10.
10. Very good. So this is log 10 plus log of this. And last step, you will put this 10 times this, right?
Yeah.
Right. So this become log. And then on the upper parts, you have 90 times square root 5. On the bottom, you have x. Okay?
Okay.
Let me see. Do number 6, all the students. Let me see if students can handle this question by yourself. If you think this part you have trouble, or you feel shy to ask me a question, after the class, you stay with me. You can ask me for help. That's pretty good, Daniel. Pretty good, Cindy. Haley, very good. Kathleen, very good. Kathleen, you want to do extra step. There's something you can Kathleen, double check your work. Something messed up. Claire, that's correct. And you need to send me your work, not just the final answer. Sudisha, Vanessa, there is your work. Abby, I didn't see your work yet. Joanna, also. Thank you, Joanna. Thank you, Kathleen. That's right. That's right, Andrea. Okay, later you check my video and make sure you fix your problem. Okay, number 6. Number 7. Sudisha, let's do number 7. What do you want to do for this one? This is 8, so what you can do? This is 8, this is 4. The formula we had previously is a to the power of log base a of x is x. Why this is always true? It's because log base ax equals to 8 itself, always. And then a to the power of this equals this. A to the power of this equals this, okay? And then when we want to do this, we want to convert 8 to 4 to the power something. 8 is 4 to the power what? First 8 is 2 cubed, right?
Yes.
And then 2 is 4 to the power 1/2, right?
Yes.
So this becomes 2.
4 to the power 3/2.
When we have here, we are going to move this guy to this shoulder. These are the same, it's gone. That's it. If you want to write down this radical, that's fine. Makes sense now?
Yes.
It's always manipulating basis. Okay, so we have to make sure know all the number 2 to the power 1 all the way to 2 to the power 10. 3 to the power 1 all the way to 3 to the power 5 at least. And all those perfect square number, perfect cube number, that is our number sense foundation. If you don't have this foundation ready, stay with me after I give you all those cheat sheet so that you need to remember by yourself quickly to be able to handle the test. Next one. This one, Abby. Abby, this question is too easy for you. Let me get a. Let's go ahead to number 17, Abby.
So
4 is who?
2 to the power of 2x
Square 2 is who?
times 2 to the power of 1/2.
over
2 to the power of 5.
yes over the right. Who is
2 to
this?
the power of -2
Mhm.
and 2 to the power of x over 3. Wait, 3 over x.
Thank you. And then the left become
2x plus half to the power. Wait, oh yeah. Wait. Oh,
yes
minus 5.
5 equals
2 to the power of -2 plus 3 over x.
okay. We can make this base to be gone, so we have 2x plus this equals this, right?
Yes.
Let's times 2x for each term. How about that?
Okay.
2x is a least common denominator, so everybody times 2x. First term becomes 2
4x squared
plus
x
minus
10x
equals
-4x
plus.
plus 6.
Good. And then when you move around, okay, let's go ahead factoring. You want to do 1 by 4 or 2 by 2?
1 by 4. Wait, yeah, okay.
And then we do 2 by 3. It's not working, right?
No, so 1 by
1 by 6 is still not working, right? Let's try 1 by 4. And then we try 2 by 3, right?
yeah.
Yeah, it's working. And here negative. Correct?
Yes.
So this becomes 2 who times who?
X minus 2 times 4x plus 3.
So x become?
-3 over 4 and 2.
Okay. That's it. And people say, do I need to worry about the negative solution or positive solution? This is exponential one. You don't worry. If it's logarithm, you have to check. You have 2 solutions. Okay. Next one. Joanna, let's do 21.
Okay.
This might be the first time you see a number appear here. This is something new. If you have 2 log x, this is log base 10, so x squared. This 2 put on shoulder, this is square.
Yeah.
They put square on this location. There is a new meaning. This log square here is saying you do the log first, log base 10 first, and then you do the parentheses, then you do square. Okay? This is same as this. Okay? But this one equals this one? No. This 2 doesn't equal. This is doing x squared first, do logarithm. This is doing log and do square. This 2 doesn't equal. Okay? So we can treat.
Yes, it'll be 2 parentheses log x parentheses square equals to
Minus, we can move this around. Okay?
Oh, yeah.
Now
So
we move this around, and then we can factor in. One, two, two, one, negative. So this is who times who?
it'll be x minus 2.
This is if you are not very comfortable for doing this way, you do this as u sub. So this means 1 times u minus 2, 2 times u plus 1. Okay?
Okay.
Yeah. If you are okay for doing this in one step, you just put this in one step. Both fine, as long as you are very clear about what you are doing. Both ways are fine. U is log base 10 of x. Okay?
Okay.
So log x equals 2. X will be who? X will be 10 to the power 2, right?
Yes.
Which is 100. And this one is x equals 10 to the power negative 1/2, right?
Yeah.
So which is 1 divided by
1/100.
square root of 10.
Oh, sorry. Yeah.
Square root 10. And you cannot leave this on the denominator. The times square root 10 for top and bottom. So you have this. That is the answer. Either that or that. You have either 100 or square root 10 over 10. This symbol is something new. If you never see this before, make it clear. These two are totally different. Don't get confused. So if you have log, this is log base 10. This one here. If you put this as 2, you will see that is the same as you put this guy square. Okay, yeah. But if you do log x, and then you do parentheses, and then you do square, it's totally different. Okay, it is totally different. Next. So far, any question? Let me see if there's still hard question. I don't see very hard question. Okay. Before I go to the new topic, any question for this worksheet? This is solving those log and exponential equations. And then we do this simplifications, inverse functions, composite functions, log and exponential graph. If no question, we will move to the worst problem, okay? Now let's go to here. First, make sure you are clear about these 5 formulas. The formula actually are very close. Compound interest is not something new. You learned this suppose in Algebra 1. This is the base money you put into the bank. And the R is the annual interest rate. This is the compound interest. If you have annual interest, annual compound, that means 1 time 1 year. N is 1. You just do the T years. If it's quarterly, then you divide by 4, and here 4. If you have semi-annually, you divide by 2, and then you put 2 here. If it's monthly, you put 12. You put 12 here. Now this one is something old. And the growth and the decay are always using this. Okay? C is the initial value. K is the decay rate. E to the power kt, e to the power rt. These two actually are all almost the same, just by different meaning. Here is talking about money, so P is the money. Here is about those kind of virus. So this is the initial value, initial amount of the virus. The K, if K is positive, it's growth. If K is negative, it's decay. And then you see the appreciation and depreciation. Appreciation, like your house. You buy the house and each year the price is increasing. So that's called appreciation. Depreciation, like you buy a car. Immediately the time you buy the car, the value is going to be depreciated. So over 10 years, your car's value is only like 0.1%, 0.1 of the initial value that you buy it like 10 years ago. That's the 5 formulas. The formula is not hard. The hard thing is how you apply it. So I will go through the examples. Go ahead. This one is using the formula we have just now. So hold on, I'm going to do this. So what I'm going to do, I'm going to delete everything. I will give you the formula so that you can manipulate with the formulas. This one is exactly using this formula here. Compound interest. That's the formula you want to use. Okay, go ahead. Number 1. How do you manipulate this formula for solving part A? Continuously. This is not a formula for continuously. So you will use this continuous formula, which is this. Everybody go ahead, do number 1. Semi-annually. You definitely need your smart calculator to help you. Anybody need help? If you want me to go through with you, go ahead, unmute yourself. Claire, how do you do this number one? Tell me, how did you do this one? Part A, go ahead.
I did 1,000 equals 500
Times
actually
who?
1 plus 0.06 over 2
To the power of
power of 2t.
2 times t. Okay.
Mhm.
And then
Divide both
Wait.
sides by 500.
and the left side is 1,000, right?
Yes.
This is the ending money. So we want to solve this. So 1,000 divided by 500 is 2. So 2 equals to 1.03 to the power 2t, right?
Yes.
That's the reason we learned the logarithm. If we don't know logarithm, we cannot solve it. This 2t is log base of 1.03, right?
Yes.
That's, and then divided this guy by 2. Some people, oh yeah, divide by 2 here. 2 over 2 is 1. No. Do this first and then divide by 2. That is the t. Correct?
Yeah.
How do you do compound continuously?
You do 1,000
Equals
500 times e, then 0.06 e to the power of 0.06 t.
this, right? Yeah. And you can check, is this 2t close or different? And who is smaller, who is greater? This one, first t, how much? See here, if we do this log base of 1.03 and then over, and then 2 inside, and then outside divided by 2. So this is 11.7 years, right?
Yes.
This one here, when we want to do this, we have to say 2 equals to e of 0.06t. So 0. This is ln of 2.
Of 2 equals 0.06.
Right. So if we do this guy, we will use ln of 2 and then divide by 0.06. Okay. 11.55. Compound continuously is going to, of course, reach to the target money the quickest. Okay. But because this rate is very small, so these two numbers won't be too much different. But if the credit card company charge you 25% interest rate, then this two number will be very big difference. Right now here, 6% is not too big. So these two number, there is a difference, but not too much. Now, number 2. Sudisha, tell me how you want to solve this one. This is what? This is a growth or decay?
Okay.
Decay. So the target, the new or the latest is which number? The target or the final is this small number, right?
Yes.
And the initial is who? The initial is who? Oh, sorry, hold on. The population will be 50,000 So sorry, I put this in the wrong direction. This is the new population, right?
Yes.
This is the initial population. And then it decreasing at this rate. It decreasing at this rate, so that means how much is left. This is amount being decreased. So what's the amount being kept? 1 minus, right?
Yes.
1 minus 2.375% to the power of who? To the power of who? 1 year, you have this amount left. After t years, you will have this guy to the power t, right?
Yes.
So now how do we solve this? We have the thousand cancel, so you just have 50 over 123, right?
Yes.
Equals to 1 minus this. So this is 0.02375. If we minus it, it's going to be 99.07615. Yes?
Yes.
And then to the power of t. Okay? And then we want to do this guy. That makes sense?
Yes.
I need to put this guy here. Right?
Yes.
And then we can do log. We will treat this guy as our log base. So we will do log this guy, and then here 50 over 123, right?
Yes.
Okay, so we will do this guy here. And then put this guy here. This is a fraction, 50 divided by 123. Okay, so that's about 37.45 years. Okay, this is decay. Next one is the bacteria. So look at this. Let me call the next student. Andrea, you can read the question and tell me how you want to do this.
Using.
So this is the growth or this is decay?
It's growth.
So this is those bacteria or virus. So look at this formula, which one you want to use.
Appreciation.
Appreciation is for those population or house values. Depreciation is for those cars. We want to use the growth and decay. Okay, yeah. So C times E to the power KT, right?
Yeah.
That means if we do C equals to, so here, the formula here, we want to have C, the value, final value, times E to the power of KT. And it said it doubles every 3 hours. So that means if Y equals this, that means Y divided by C is 2. So you can say 2 equals to E to the power of K times 3. after 3 hours, it get doubled. Make sense?
Mhm.
And then we want to say solve the K, right?
Yes.
So how do we solve this one? We want to take the which log? Log base what?
Um,
Natural log, right?
yeah.
So we will take the ln of both sides. That means ln of 2 equals to 3k. So k is ln of 2 over 3. Make sense?
Yes.
And then the question is not finished yet. They said initially they will have this amount. Initially has this amount. So your K, this is your growth rate. So this is the growth rate. You get this one and you see this is the growth rate. And they ask you the amount of time when you have 100,000 bacteria. So that is going to be your target. You want to make this guy as your new target. Who is the initial?
2500.
2500 is the initial times e to the power who?
Ln 2
KT, right?
Yeah.
So you have ln of 2 over 3 times t. Make sense?
Yes.
So you want to solve this. Let's see, how do we solve it? This guy divided by this is how much?
It's
100 canceled. 1000 divided by 25 will be 40, right?
wait, yeah.
So far so good.
Yes.
And then you want to take the ln for both sides again. Take the ln of this, that's this. Take the ln of this is gone. You have this, correct? So ln of 40 equals this. And then you want to further solve this t. So you want to use that guy divided by that guy. So you will do ln of 40 over the top. And then for the bottom, you do a fraction over the top here is ln of 2. Here, 3. That means the amount of time is 15.97 hour. Yeah, and number 3, number 1, number 2, simple. It's pretty straightforward. Number 3, this is those typical questions students always got confused. They thought they solve it already. No, this is only part. You are going to be asked a second parts. Based on this rate, what is the time to be able to reach to a new value? You want to use the guy here to plug in here to solve the t. This is what's going on for number 3. This is very typical question. If you still feel confused, you can ask me. I will walk through with you again. Does anybody need help for number 3? Next, I'm going to talk about the half-life. The half-life also very confused. This one here. Those radioactive substance, they always talk about the half-life. What does this mean? That means after 65 days, the guy is going to reduce to the initial amount by half. After 65 days, 1/2 is gone. Only 1/2 is left. So based on this, just one number, you will be able to solve something for your decay rate. So anybody want to challenge this question? You have this, and then you can solve your decay rate of K. Who knows how to solve this? Your decay rate? Any students here learned the chemistry class in your school already? Chemistry AAC? No student learned chemistry AAC yet, right? This is those exactly same chemistry question that you are going to learn in your high school. Annie, let's do this one together. You have a half left. That means 1/2 is left. Okay? So that means y over c is 1/2. So you don't need to worry about how much is your c. You don't need to worry about your y. You just know y divided by c is 1/2. 1/2 is left. E to the power of kt. How many days you have 1/2 left?
65.
So you have 1/2 equals e to the power of 65 times k. Make sense? Okay. So we will be able to solve k. We do ln 0.5 and then divide by 65. That is a k, right? You take this and this guy is gone. Ln 0.5 divided by 65, that is k. When we draw the ln, when it's 1, it's 0. Ln of 1 is 0. If it's greater than 1, it's positive. If it's less than 1, it's negative. So this guy is negative. When this guy is negative, it is decay. When this guy is positive, it is growth. That's why here, this culture is double. This guy is decay because this coefficient k is negative. That's why it is decay. E to the power negative number is going to going down. It's less than 1, so you are decay. E to the power positive is going to bigger than 1, so you are going to growth. So you have the k decay rate here. Next, look at here. How much is this?
3.5.
That's initial. So you want to do 3.5 times e to the power kt, right? K is given. We already solved the k. This is time for us to plug in. So you copy and you paste to this shooter. And then you times t. You want to reach to how much? 1, right?
Yeah.
So you make this to be 1. And then you want to solve your t. How do we solve this t? We will do the ln. We will do 1 over 3.5 equals to this. Correct? And then we will do ln. So we will do ln of 1 over 3.5 equals to ln of this. Well, this is e. Ln of this. E and this canceled. So you have this. So you have that guy over that guy times t. So t is going to be this guy divided by this guy. Okay? So what we do here, this is 1/3.5. And over here, this is ln of 0.5. And this number here is 65. So the answer is after 117.48 days. Number 6 and number 3. These two are those typical examples. If you can understand 3 and 6 truly, and can do this too by yourself now, you already mastered this part. You have nothing to worry. But I don't know if students truly understand this number 3 and number 6. I delete number 3 and number 6. Go ahead, do number 3 and number 6 by yourself. And also you need to use calculator to give me the correct final results. Not only show your work, but also calculate these two values. If you say, can I go through with you one more time, unmute yourself, I will go through with you. Doesn't matter it's money or population, it's bacterial or virus or radioactivity substance. Something is going up, it's called growth. Something is going down, it's called decay. If it's population, you use this growth. Or if it's car depreciation, you use the decay. If it's for those natural stuff, like those bacteria, you use the growth model. If it's those radioactivity substance, you use the decay model. Pretty good, Catherine. As students, send me your work. Let me see if you truly can do this too, independently by yourself. Why just one student send the work? Daniel, it's hard.
It's a little confusing. I'm not sure what is half-life the constant rate per unit of time?
No, this is not a linear decay. It's not like you decay like 5 grams every 1 hour. It's not that kind of decay. It's those kind of exponential decay. Okay. So this is called the decay rate. This is those exponential decay. It follows e to the power kt as those kind of graph. 1/2 half-life means after 65 days, you only have 1/2 left. If originally you have 100, after 65 days, you only have 50. So 50 over 100 is 1/2. 1/2 equals this. And when you have this, you will do the ln for both sides. So ln of 1/2 is ln 0.5. Ln 0.5 equals to this. You divide by 65, you have the k. K is the decay rate. You don't say it's a constant rate. No, it's an exponential decay rate. And then you have this decay rate. You will follow this decay model. Your initial is 3.5 gram. Your final, you want to be less than 1 gram. So 1 is here. You want to reach this. You want to see how long. You follow this decay model. You use this decay coefficient. You pull this one over here. You want to calculate your new amount time. This gave you that. You can see here, when you see a result, you want to tell if it's reasonable, if it makes sense. 1 over 3.5. That means you decay more than half. You decay 1/2, you take 65 days. So you decay more than 1/2, you will be a number greater than this. So if this number you give less than 65, of course it's going to be wrong. You decay more than half. That's why this number should be greater than 65 days. Yeah, Andrea, pretty good. Really, very good. Annie, very good. Ethan. Okay, you get the number 3, but you haven't finished number 6. Okay, it's already 8:10. If you have question, you leave with me. If you don't need any additional help, you can leave. Me your question.
I wanted to hear the explanation for number 6 one more time.
Okay. So half-life, for example, originally you have 1 gram. After 65 days, you only have 1/2 gram left. This is saying you are using 1/2 as your new value. 1 is initial. This is following this decay model, e to the power of kt. So 1/2 over 1, which is 1/2, and e to the power 65 times k. You want to take the ln of both sides. if you do this lane and you do this lane, you know this guy you can pull in front, right?
Yeah.
If you do lane, you pull this one in front. Lane of E is 1. So you have lane of 1/2 equals to this, correct?
Oh, yes.
Lane of 1/2 just less lane of 0.5. And you divide by 65. This is K. Okay?
Oh,
Yeah.
wait, so lane of E is 1?
Lane of E is 1.
Okay.
Lane of E is 1. That's why, because lane of E is log E of E.
Okay.
Because E of E to the power 1 is E. Okay? So you have this guy here, and you got this K value, right?
Yes.
After you have this K value, you are going to put this whole thing as your new model here. This is the same model, but the value here changed. This is 1 here. This is 3.5 here. 3.5 is the initial, 1 is your final new one. They ask you after how long you will reach to 1. You have this decay coefficient. So you put here, you use this to calculate the t. Make sense?
Yes.
And then you divided this by 3.5. So you have ln of this equals to same thing here. 1 divided by 3.5 equals this. When you do ln, this guy is going to pull in front.
Yes.
Ln of E is 1. So you have this equal. You have
Oh,
this. Okay?
yes.
Yeah? Because ln of E is 1. Log base A of A is 1. That's why this can be gone. That's why we need to learn natural log.
Okay. That makes sense.
Yeah, all those real world stuff, like those radioactivity stuff, they follow those natural log decay. Yeah. In chemistry, you see similar question, right?
Yeah.
Okay. You have any other question?
No, that was it. Thank you.
Okay. Okay, bye-bye.
Bye.